Stephanin's Endgame.
Hi, I was working on a video to explain my journey out of young Earth creationism, because even after I left religion, it took me months of careful examination before I could change my mind about the age of the Earth or evolution. However, I thought it would be beneficial to walk through the process I used to determine whether a claim was true. This process works well for any claim that asserts a scientific backing. For example, I grew up thinking carbon dating didn't work at all. There was a story about a creationist who had a piece of fossil wood radiometrically dated, and it came back only a few thousand years old, even though it was discovered in a region of rock supposedly millions of years old. That claim has been circulating for a very long time, and most people in my religious circle, including myself, believed it without ever actually looking into that claim. So instead of just telling you about that claim, I want to show you the process I use to determine whether it is true. This is the same process I'd use for any claim on any side of the argument. This video isn't about whether creationism is true, it's just what the process actually looks like. Here's the claim as I first heard it. Fossilized wood, supposedly millions of years old, was tested for carbon-14, and it came back dated somewhere between 30 and 40,000 years old. This claim is specific and testable, which makes it an excellent candidate for examination. The first step I need to complete is to find where this claim actually came from and what it actually says. So I begin with a very general Google search for fossilized wood younger than 50,000 years. So Google now provides an AI overview, which is very handy for getting a quick summary of something like subfossil wood. We even have here an explanation of carbon-14 dating from the University of Chicago, which is fantastic. We can come back to that a little bit later. I'm still interested in finding the claim itself. Now the first result here is on fossil ammonites and wood, and I have another Wikipedia entry and radiocarbon in ancient fossil wood. This is more along the lines of what we were actually looking for. I'm going to skip this one for now, and I'll come back to it in a little bit just so you can see why. But as I scroll through the results, I see one called the Geological conflict here. I'm not sure if this is one of the articles I'm looking for or not, so I'm going to scroll down to the conclusion. That's a good way to get the summary of what happened in this paper and kind of their point they were trying to make. So fantastic, here is the conclusion. The fossil wood in the top 3 meters of the Marlstone rock bed near Banbury, England, has been carbon-14, so 14C carbon-14 dated at 23,000 to 23,500 years BP. So I just did a quick search online for what BP stands for, and that just means before present. So we don't actually, it's not actually that it's been dated at 23,000 BCE before the Common Era, but it's actually before the present date. That's how the carbon-14 dating kind of works. However, based on evolutionary and uniformitarian assumptions, the ammonite and belemnite index fossil in this rock date it about 189 million years. Obviously, both dates can't be right. So this sounds what I was looking for, or what I could remember about the claim, but this is just a web posting here. So it could be posted by anyone. They may have misunderstood the published article somewhere. They might have added some information, that sort of thing. So at the top here, they've gone ahead and said, okay, this first appeared in Creation 22, issue 2, pages 44 to 47 from March 2000. Fantastic. So that's what I'm going to search for. I'm going to try to find this original publication. I'm going to give this search a try. It's a little difficult because the name is Creation and it's a little difficult to find an actual journal called Creation, but we'll take a look and see if we can find it. At the top result here, I can see creation.com, all creation magazines. So that's fantastic. I can just simply go through and try to find the year 2000 in March here. So let's take a look for that. Year 2000, March. Here we go, March 2000. So volume 22, issue number 2, March 2000. So we can take a look at the page that drives us to here. And we can see if we scroll down, we should see this geological conflict entry. Here we go. And it's taken us back to the same page we were already on, which is, it's all right. That's not the end of the world. It looks like this is how they're maybe publishing their articles. It's perfectly fine. So I can see this was by Andrew Snelling. So that's, looks like who was the author of this. What is interesting, though, this was originally published in March of 2000. It's written by Andrew Snelling, but it has been published on the site, at least, in January of 2006. Ideally, I would like to find the published article as it originally appeared, but for now, this is fine. I'll just make a note that I should continue searching for the original article a little later on. There should be an archive somewhere that would have the original. So next we should do a little background check about the author. This is useful because we want to see if this individual is taken seriously among his peers. I'll use Google Scholar for this, which focuses on publications rather than simply web posts. That's just scholar.google.com, and I'll do a search for Andrew Snelling. So this is showing some of his works, which is fine. But typically, we would see a profile for him in Google Scholar. So normally, you'd actually see a profile that you could find out a little bit more about the author. But we can Google another example, for instance, just to get an idea of what the profile would be like. So if I Google P.J. Reimer, so this is for Paula Reimer, I believe, we can actually see some information for them. So we can click on their name here and we can see the number of citations. So that's the number of citations from other people. So other people have cited their work, and we can see that they're from the University of Belfast here, Queen's University of Belfast, and that we have some of their publications listed here, which is quite a few, it looks like. So this is typically what you'd see for a profile on Google Scholar. That's not the end of the world that we didn't find that. It just means I'll have to go back to regular Google for doing a search on Andrew Snelling. So we have here Andrew Snelling, fantastic Google search. We've got a Wikipedia entry here, and we also have a profile from Answers in Genesis. So let's take a look at that. So it looks like Andrew has a PhD in geology, which is fantastic. That's the topic we're talking about, from the University of Sydney in Australia. And it mentions his research and writing career on topics such as flood, fossils, Grand Canyon, radioactive dating of rocks, etc. So this is fantastic. We might want to do a little more investigation with Andrew Snelling. So I'll just make a note that I should do a little more thorough investigation of Snelling later on. So I'll take a look at this article that we initially skipped that I said I would return to, so I want to make sure I do come back to it. So this one is from the Institute for Creation Research called Radiocarbon in Ancient Fossil Wood. Here we have the article, and again, it's just a web page posting, but it might be a posting of the actual article, which is fine. We can see it's from the Institute for Creation Research, the title. We can see this one was written by Andrew Snelling as well, and it was published in 2008. At least on this webpage, it was published in 2008. Again, it might refer to an earlier publication. We'll have to do a little digging if we want to try to find that out. But that is fantastic. So here we have the first line of the sentence, which is fantastic. The presence of measurable radiocarbon in fossil wood, supposedly tens and hundreds of millions years old, has been well documented. Okay, this is fantastic. This is a great statement to have, right? So here we have the idea that radiocarbon in fossil wood that's supposed to be millions of years old, but isn't, right? So the idea of radiocarbon being in fossil wood means that it shouldn't be older than, say, 50,000 years. And we'll dig into what radiocarbon dating actually means. But what we see here is that this has been very well documented. And he has citations here 1 to 5, which is fantastic, right? So now we know there's at least 5 citations, 5 references to other publications that say the same thing. This is good. So we have some corroboration on this finding, which is fantastic. So some citations that back up his claim. This brings us to step 3, which is to check what the citations actually support. So we want to make sure that they were not taken out of context, all these wonderful things. So let's scroll down and find these 5 citations. So here we are, there's the conclusion again, and here's citations 1 through 5. Now each one of these are citing Andrew Snelling's own work. So 1 to 5 here all refer to some previous work that Andrew Snelling has done. That's not 5 people confirming a finding. That's one person citing himself 5 times at different points in his own career. So if I told you I'd interviewed 5 people and they all agreed with me, and then it turned out all 5 were me, you'd rightly call that dishonest, and that's the same here. It's okay to reference and cite your own work in the past, but the strength of your argument should not rely on your own work. This is one of the differences in science, right? So in science, you want to make sure that others have been able to retest your work and verify that what you've said is true. So what's nice is we do have a citation here for that geological conflict article from 2000, and we can see it was first published inside of Creation ex Nihilo, volume 22. So maybe that is why we weren't able to find it before. So I'm going to do some Google searching and try to find that article. So I've gone back to Google Scholar here and searching for Snelling geological conflict using quotation marks so that it keeps these 2 words together. So it's looking for that exact sequence of words. And down here I find the actual article itself, but unfortunately it's only a citation. So we have citation Google conflict, so I can't actually go to that article. After a little more searching, I finally found this article. It says conflicting ages of tertiary basalt and contained fossilized wood in Australia, here, location in Australia. So it is again written by Andrew Snelling. So it's written by Andrew Snelling, which is fantastic. And it's covers the same kind of content. So it's on a different site than the geological conflict article was, but this will do. What I like about this is it's actually a publication, so this is what you would have received. The print version probably looked like, at least a lot like this. So this would have been the similar time that the other one was published, which is interesting. So that brings us to step 4. So check who actually reviewed it. So we want to look at the actual publishing process that Creation ex Nihilo uses. Creation ex Nihilo means creation out of nothing, by the way, which is interesting. After a few searches here, I've come up with a search for Creation ex Nihilo journal history. This is going to give me a little bit of background about the journal at least. So it does mention here the summary is useful. Again, that it mentions that its name changed a few times. That's probably why it's been difficult to track down. Originally, it was ex nihilo technical journal, then Creation ex nihilo technical journal, and then shortened in 2003 to TJ, and then it's been rebranded as the Journal of Creation instead. So we can confirm this AI overview from creation.com. This is the publisher, as far as I can tell, or the owner of that publication, maybe. Which has that same information in this article here. So if we scroll down in this article, we can actually see the name changes taking place over the years. So I did another search here trying to find out, basically I want to find out about the journal history, a little bit about the publication process, that sort of thing. As I was doing the search here, I have Creation ex Nihilo technical journal editor. I'm basically looking for the editor history or who kind of ran these types of things. And I can see here that it was actually the founding editor. So the founding editor was Andrew Snelling here, which is kind of interesting. So digging a little deeper into that. So just remembering that this is just an AI overview. So we want to do our due diligence and check into that a little bit more. So this actually kind of brings us back to this profile page that we found for Andrew a little while ago. And there's an interesting paragraph down below here that, as well as writing regularly and extensively in many international creationist magazines, journals, and publications, Andrew was the founding editor in 1984 and served as editor for almost 15 years of the Creation ex Nihilo technical journal, now the Journal of Creation. This is significant because it means that Snelling was running the journal when he submitted his own work. And that's not peer review at all. That's like being both the defendant and the judge in your own case. So for anything Snelling published before 1999, so almost 15 years from 1984, so for anything Snelling published before 1999, the conflict of interest is direct and doesn't need much more digging than that. But let's go back to that citation we had from the ICR article. So this was the ICR article, the Institute for Creation Research here, with that one article we looked at, radiocarbon in ancient fossil wood, where Snelling has cited himself 5 times. If we go back to this location, we can actually see at the very least 2 of these submissions occurred when Snelling was the founding editor. So you can effectively treat these as being self-published works here. The remaining publications take place just after he stepped down as editor, but we don't know how much influence that he would have had during that transition. So it's possible he still had a lot of influence there. So it would take a lot more digging, but it does show a pattern of how this journal operates, or at least how it used to operate. So after a little more digging here, finding the creation.com, the publishing requirements. So this one here says for the Journal of Creation, so that formerly the Creation ex Nihilo technical journal, the Journal of Creation, is dedicated to upholding the authority of the 66 books of the Bible, especially in areas of origins. All our editors adhere to the Creation Ministries International Statement of Faith, and most papers will be designed to support this. This is essentially saying that to publish in this journal, you are required to have a bias. Submissions have to already agree with a biblical framework to be considered for publication in the first place. This is the exact opposite of what we should attempt. Science is aware of biases and makes every effort to reduce those, not to reinforce them. That can significantly skew the results of data interpretation. The bias requirement essentially says, state your conclusion first, and then find evidence to support that. At this point, I've learned plenty about who made the claim, where it was made, plus the kind of journal that was publishing the claim. Let's do one more piece of investigation before getting into the content. So now that I actually have a name for an actual journal article, we can actually go into Google Scholar and search for that article specifically, which is fantastic. And here we have cited by 18. So this is the number of times this article has been cited by others, which is fantastic. This is great for checking whether anyone has rebutted this or confirmed it or built on it further. Unfortunately, though, every citation here appears to trace back to other young Earth creationist sources, so no independent person has weighed in on this specific paper in either direction. Now, this is really important because mainstream radiocarbon science doesn't need to respond to every paper published outside a peer review system to keep doing accurate work. The absence of a direct rebuttal isn't a gap in the science. It's what you'd expect from a paper that was never part of the conversation. So we've reached a dead end with this one, and that's fine. Dead ends are a normal part of this process. Once you hit a roadblock, you just have to go looking elsewhere. So this means I'm going to have to get my hands dirty and do some of the footwork myself. So this is where I need to leave all the young Earth creationist sources behind and get into the radiometric dating science myself. So step 6 is understanding the problem and its components. Before I can examine whether Snelling's article was accurate or contained any flaws, I need to learn some of the basics. what is carbon dating, radiometric dating, etc. So it's time for some more Googling. So for right now, I'm just going to read through the AI summaries because this provides a nice little basis. Once I get a little more serious on the topic, of course, I'll want to go to actual publications that deal with these definitions and learn all the details. But for right now, this is good. Radiometric dating is a technique used to determine the absolute age of rocks, fossils, and artifacts by measuring the decay of unstable radioactive isotopes, so parent atoms, into stable isotopes, daughter atoms. Because this decay happens at a constant, predictable rate known as a half-life, scientists can calculate the time that has passed since the material formed. So let's do a search here for carbon-14 dating as well. Carbon-14 dating is a method used to determine the age of organic materials by measuring the decay of the radioactive isotope, C-14, basically carbon-14. Developed by Willard Libby at the University of Chicago, it is widely utilized across archaeology and geology to date artifacts up to 50,000 years old. And how it works is absorption, so cosmic rays enter the upper atmosphere and create carbon-14, which plants and animals absorb while alive. Decay: upon death, the organism stops taking in carbon-14, and the existing carbon-14 begins to decay at a steady, predictable rate. Measurement: scientists determine an object's age by measuring the remaining ratio of carbon-14 to stable carbon-12. So key details: half-life. The half-life of carbon-14 is approximately 5,730 years. This means it takes 5,730 years for half of the carbon-14 in a sample to decay. Calibration: because atmospheric carbon levels fluctuate over time, raw radiocarbon ages require calibration using data from other dating methods like tree ring dating, dendrochronology. Limitations: this method is generally limited to samples that are less than 50,000 years old, as older materials contain too little carbon-14 to be measured accurately. So that's where we get the possible duration of carbon-14. It's generally thought if you can test carbon-14 in some material, then that material must be less than 50,000 years old. So this is good. Now I have a general idea of what we're talking about. I want to go on to the next stage, which is step 7, going into the literature. So I'm going to go back to Google Scholar, and this time I'm going to search for radiometric dating fossilized wood. So that's the topic we're talking about. We're avoiding the creationist sources here. And here we have the first article, constraining the age of last interglacial glacial transition in the Hudson Bay lowlands, Canada, using UTH dating of buried wood. So let's check out that article. So fortunately, I have access to this through my library. Sometimes that is something that trips you up when you're trying to find mainstream research. You may be blocked by a paywall. You can usually get access to that article through a library, or you can even reach out to one of the authors directly. They're usually happy to talk about their research and help budding researchers. This paper is laid out like a standard research paper, which is kind of nice, since we have the abstract that we can read through and find out what this paper is getting at. One of these areas I've highlighted here is the radiocarbon dating of wood log yielded an age beyond the effective limit of this method. What that means is they were not able to find any significant amount of radiocarbon dating in this particular wood log. So we need to read more, of course, to see what's going on here. So we can read through the methods that they used here. One fragment of wood was sent where they sent it to, that sort of thing. We come to this part on page 43 here, which mentions that the C-14 dating of this particular sample, this particular log, had a non-finite age. So they weren't able to find a substantial amount of carbon-14. And they mentioned this is consistent with more than 20 dating attempts carried out on wood and peat from various locations as well. This raises the question of whether other scientists are not seeing the same issues that Snelling had when using proper preparation and preservation methods, even on wood. So in this article, about 100,000 years old. So it's much younger than the wood that Snelling was claiming still had carbon-14 detectable. So later on in this article, we can see here that how contamination can affect fossil wood, but it requires a bit more knowledge of dating techniques. So living trees don't absorb any uranium in a meaningful amount, but once buried, groundwater carrying dissolved uranium percolates through the sediment and gets absorbed into the wood structure over time. So uranium, this is U-238, has a multi-step decay chain that eventually ends up being converted into thorium-230. The comparison here are uranium-thorium analysis indicate that the sample collected from a live tree near the study site has extremely low uranium content, compared to fossil wood samples that show uranium concentrations 60 to 2,700 times higher. So this is showing that live trees don't contain meaningful uranium, where the fossil wood samples do. So this is a good methodology to establish a control group, showing that modern trees do not pick up uranium on their own. The authors note that fossil wood became contaminated by external thorium-230 carried in by degradable clay particles during burial. So in spite of the mechanical cleaning of the outer surfaces of wood fragments, all fossil wood samples contain non-authigenic thorium-230 as indicated by a variable amount of thorium-232. So thorium-232 related tests, they are able to determine that there are non-authigenic elements. So here the presence of non-authigenic, so things that did not form essentially natively to the material itself. So the presence of non-authigenic thorium-230 in the fossil wood samples thus requires a correction for this contamination. And several correction methods can be applied to impure material or samples containing detrital particles. The paper goes on to explain that the correction methods they use account for this contamination. What's useful to note is the goal of this paper was to find a way to correct for thorium contamination automatically using this 3D isochron. However, as you can see from the sentence here, however, as shown above, the calculations derived from the 3D isochron clearly show absence of a linear or statistical trend. Basically, what they're saying here is that their experiment didn't work out the way that they were hoping. So in science, we want to identify your own shortcomings as best you can before someone else points them out. Of course, you'd want to go through the regular checks that we did with Snelling's work by checking out this particular publication, right? We want to go through the publication, check out their history as well, all of those wonderful things. We want to have corroborating evidence. So this particular work, how many times it was cited and used, all these typical things that we do. Google Scholar, looking up the primary author. Generally, you have many authors on a table, and you can see here they have the profile as well, how many times they've been cited. So this is most, I'm guessing, maybe a younger author or someone that hasn't or has left the research industry. Could be any number of things. But we can see that they have been cited by quite a number of citations. So they were cited 147 times, which is fantastic. We can look up the name of the journal itself, Quaternary Geochronology, and you can go through that history and see that they have quite a prominent history. They're quite well recognized. And it's useful to note, this is the very first article that we looked. We just went on to Google Scholar, Googled for some terms, and this is the very first article that we even looked at here. So as we continue to read through these articles, we would see that things like groundwater, humic acids, and handling all can introduce trace modern carbon into material, and older or more degraded wood is more vulnerable to this, not less vulnerable. we can take a look. There's a publication here. There's a publication here from Radiocarbon on the radiocarbon dating of highly degraded and problematic fossil wood. So here they actually have some instructions on the proper preparation. So hopefully you were able to note that none of these sources needed to mention Snelling by name at all. They're just describing independently how this exact kind of result that Snelling was talking about gets produced by contamination rather than by wood being young. From the literature, it looks like mainstream science identified some of these issues with radiometric dating fossilized wood. They tested it and discovered that proper methodology solved the issue. This is exactly how science works. We discover an inconsistency and test it thoroughly from all angles. If there is an issue with radiometric dating fossilized wood, we want to find it. But we're still not done. So we want to go through Snelling's articles, make sure that we've read them thoroughly. And he does have some disclaimers about potential contamination. So in this Geological conflict article of Snelling, it says, could radiocarbon be due to contamination? He mentions 4 reasons why not. The first one is that they've sent the samples to 2 laboratories and they independently obtained similar results. So that's fantastic, right? That is a good point to check. So they've sent the samples off to 2 locations and had the results independently verified. But that only rules out contamination happening at the labs. It says nothing about whether the wood picked up modern carbon before it ever got there, since both labs would still agree with each other, even if they were both measuring the same already contaminated sample. The second point, that unavoidable contamination caps out around 0.2% is correct, a cited figure, but it's generally background estimate for routine lab conditions, not a measurement of this specific sample's actual history. And it doesn't account for anything unusual that might have happened before collection. And the third point here, that the delta carbon 13 consistency shows the carbon is plausible from a land plant, but modern contamination, fresh plant debris, fungal growth would likely show very similar signature, since it's often the same broad category of organism. And the fourth point isn't really evidence at all. It argues that doubting the result would unfairly insult the credentials of the lab's PhD staff, which has nothing to do with whether the measurement is actually correct. Credentialed people at good labs get unexpected results and undetected contamination all the time. That's exactly why science leans on independent physical tests rather than trusting experts as a guarantee. And that's really the pattern worth noticing across these 4 reasons. None of them is an actual diagnostic measurement. Nothing like argon ratio or the thorium index that we saw in that other paper that could tell contamination and intrinsic carbon apart on physical grounds alone. This other article by ICR does something very similar. Under discussion here, he mentions the 4 sources of potential contamination. And again, similar ideas, right? This one is a sample from Cripple Creek instead in Colorado. So instead of the one from Australia, but he mentions the same or similar ideas of contamination. Once you've seen what a real scientific publication actually documents, so measure backgrounds, correction indices, disclose statistical fit, the 4 reasons of Andrew Snelling presents are very different. These are arguments and not evidence. The lab contamination point claims none occurred because the lab's process would have removed it, but that's just a claim again about the lab's general competence and not an actual measurement. We'd actually want the lab's own blank values, the way the uranium thorium paper reported theirs, right? So 25 pg for uranium, 150 pg for thorium, a specific number, not a description of the procedure. The handling contamination point, so this is back in Snelling's paper, is dismissed as surface only, but we've already seen a real concern from the other sources in this project that contamination can penetrate porous or degraded wood, not just sit on top of it. third argument here, the source area argument, rests on two things: that no carbonate or silica was visible. This is just asserted, it's unverified. And the ancient hydrothermal fluids would have only contained old carbon. This is just an assumption about geological history stated as fact. And this fourth argument, the groundwater argument, addresses natural water infiltration in detail, but never once mentions the most obvious modern carbon source for sample collected from a working mine, the mine's own operations, ventilation, blasting, diesel equipment, human traffic, all that stuff. And that's not a minor gap. It's the most likely contamination pathway going unaddressed entirely. But most importantly, none of these 4 points is an independent diagnostic test. Nothing like the thorium-232 index from the uranium-thorium paper, which could actually distinguish contamination from intrinsic signal on physical grounds. In Snelling's work, he has this here's why contamination probably didn't happen, not here's how we measured that it didn't. And that's much weaker. Snelling's is a much weaker kind of evidence. However, we don't need to go further into the literature or trust anyone's authority. We can just look at Snelling's own reports. So let's go back to this geological conflict paper and scroll down here to his results. And we could read what he's written in the results section here. The radiocarbon, carbon-14, results are listed in Table 1, and we'll take a look at that in a second. Obviously, there was detectable radiocarbon in all fossil wood samples. The calculated carbon-14 ages ranging from 20,700 plus or minus 1,200 to 28,820 plus or minus 350 years before present. Let's go down to his table here. This is his table 1. This is the table that he was referring to in that paragraph. We have here one sample. This is UKHB1 that was sent to 2 different labs. So Geocron and ANSTO. So one sample sent to 2 different labs. So split the sample and sent it to 2 different labs. For the Geocron, we get an age of 24,005 plus or minus 600. And for the ANSTO sample, we get 20,700 plus or minus 1,200. So sending one sample, so splitting one sample and sending it to 2 different labs is good practice. But those 2 labs came up with significantly different results, and their margins of error don't even overlap. So their ages with the margins of error don't even overlap. So let's take a look at what that exactly looks like for us. Recorded all of the numbers here and just copied them over from the paper. But we can see the same sample. So these were the same samples. The Geocron UKHB1 sent to 2 different labs. So split and sent to 2 different labs. We can see their original range, or the result given plus the error range. So if we look at the lower bound value, so that is taking our average and finding the minimum result. So plus or minus 600, that gives us 23,405. The upper bound is going to be 24,605 versus the other sample here, which is 19,500 for the lower bound and 21,900 for the upper bound. We can see from this bar chart here, these 2 are the same sample, split apart, being sent to the 2 different labs. And this is the cleanest possible test case that we have because it's the same physical sample. One piece of wood split and sent to 2 labs. There's no room for maybe the wood wasn't uniform here. Whatever set that wood's original carbon-14 level, a normal atmosphere or Snelling's hypothesized altered post-flood atmosphere, that level is a fixed physical fact about one piece of wood. 2 labs measuring the same fixed fact should land within their own stated margins of error of each other, and they don't. So let's go see what Snelling has to say about this in his results section here. For sample UKHB1, that's the sample we're talking about, collected from on top of the belemnite index fossil, figure 5, the results from the two laboratories are reasonably close to one another within the error margins. And when the average yield carbon-14 age almost identical within the error margins to the 22,730 plus or minus 170 years BP of sample UKHB2. Now, just a note here, I can't find this figure 5 in this online posted version of the publication, so I'm not sure what that was referring to. We just saw that UKHB1's two results don't overlap at all, not even within their own margins of error, and averaging them doesn't make the disagreement go away. It's like stepping on two bathroom scales at once and getting 150 pounds on one scale and 130 pounds on the other, and instead of asking why your scales disagree, you average them to 140 and declare that both scales actually agree with each other. The average is a real number, it just isn't evidence that the disagreement didn't happen. So let's continue with what Snelling says here in the results. Alternatively, if all four results on the three samples are averaged, the carbon-14 age is almost identical within the error margins to the Geological result for UKHB1, which is that 24,005 plus or minus 600 years. This suggests that a reasonable estimate for the carbon-14 age of the fossil wood would be 23,000 to 23,500 years before present. So once again, averaging results from different labs and different samples doesn't resolve a disagreement between them, just attempts to bury them. And Snelling continues here, of course, uniformitarian geologists would not even test this fossil wood for radiocarbon. They didn't expect any to be in it, since they would regard it as about 189 million years old due to the age of the index fossil. This statement just isn't true. In the Allard and others paper here, the researchers did test old wood for radiocarbon, and they got a non-finite result. And they built a contamination assessment directly into their method. This isn't true at all. So in the Allard and others paper here, researchers did test old wood for radiocarbon. They got a non-finite result and built contamination assessment directly into their method. When researchers do check old wood for radiocarbon, they build in physical and isotopic contamination controls that are simply absent in Snelling's work. Now let's go back and look at this conflicting ages paper of Snelling's. On page 21, he writes, all the field evidence indicates that the wood was fossilized as a result of being entombed in the lowermost of these tertiary alkali basalt flows. The trees were apparently rooted in the Permian siltstone at the tertiary land surface over which the lava flowed. Without doubt, the wood must be the same age as the basalt which entombed it. So this flow was about 4 meters thick and would have cooled within days to a few weeks. This isn't just the same era, it's two standing trees killed by one eruption, entombed within a span of weeks. So now let's look at table 1 on page 12 here. And keep in mind, this is a different set of samples than the geological conflict paper was talking about. So here we have wood in the drill core. So again, one sample split and sent to two different labs. So the Geological result here says greater than 35,620. So they weren't able to get a precise result. And the ANSTO lab result here says 44,700 plus or minus 950. So this isn't a contradiction. So Geocron's result is a floor. There wasn't enough carbon in that sample to calculate a precise number. ANSTO's 44,700 here is a normal finite measurement, and it comfortably sits at that floor, so no conflict here. But look at the other pair here, the other wood. So samples gave two very different age ranges, 29,500 and again 37,800. Two finite, precise measurements with zero overlap between them. So again, we can graph these up if we like. We can see that the lower bound of the Geocron wood sample here is 28,785, and the upper bound is 30,303, where the ANSTO sample, the lower bound is 34,350. So we have no overlap between those two samples here, and you can see that well in the graph. So these two results came from different physical fragments, not one sample split into two. So in principle, someone could try to argue that the different fragments are simply allowed to differ. But Snelling has already closed off that argument himself. He told us this wood came from trees rooted in place, entombed by a single flow that cooled within weeks. If his own site interpretation is correct, fragment-to-fragment disagreement is exactly as unexplainable as the sample-to-sample disagreement would be. There is no version of his own story where two pieces of wood from the same standing, rooted trees are allowed to have different true ages. And so on both papers, we find the same pattern. Measurements that should agree don't. Right? So measurements that should agree because Snelling's own account requires them to be measuring the same fixed thing don't agree. Measurement uncertainty is exactly what those error bars represent. It's the lab's accounting for its own precision. When two results fail to overlap, even after accounting for those errors, something beyond ordinary measurement noise is adding to the variance. Contamination is a strong candidate because it's inherently uneven. It depends on which specific fragment picked up more modern organic material during excavation, storage, or handling. An intrinsic ancient carbon signal, by contrast, would be a fixed property of the wood itself and wouldn't care which lab or which fragment measured it. You don't need a background in radiocarbon chemistry to see that the two numbers don't overlap and both can't be measuring the same fixed thing. This is the key difference between science and young Earth creationism. Science says, I wonder how old that rock is. Let's look for a way to find out. Young Earth creationism says, that rock is at most 6,000 years old. Let's find evidence to support that claim. And all that we did just now, was only addressing a single claim, one that I heard and used in the past. And Snelling's arguments might not even be the strongest arguments against carbon-14. There will always be a temptation to jump to the next claim before finishing the current one. What about the Grand Canyon rocks? What about the freshwater mussel? There will always be another claim waiting, and that's not by accident, that's a tactic, whether or not it's even used deliberately. Stack enough claims fast enough, and by the time someone's checked the first one, you've already made 10 claims more, and nothing gets resolved. Instead, you pick one claim, follow it all the way to a source you can actually evaluate, and don't get distracted by other claims along the way. The whole process I followed took time. And if I were writing an actual research paper, this would only be the starting point. I'd still need to do a full literature review, real grounding in the concepts behind carbon-14 dating, a closer look at how the samples are actually collected and prepared, comparable studies from other researchers, and the list goes on. Now imagine doing that for hundreds of claims. And that's what the peer review process is actually for. People who already have that grounding can move through this process much faster than I could. And they can catch methodology issues and inconsistencies that I would never notice. And I think that's the part most people miss about trusting the experts. Experts have spent their entire careers researching these topics and reviewing the literature. For a layperson, the amount of work is quite overwhelming. Doing your own research does not mean finding a website that supports your claim. It means learning the fundamentals and investigating the claims. And I'm not trying to convince you in this video that carbon-14 is a flawless system. I'm showing you the process it takes to actually check a claim. That's what real research looks like, following it all the way to the source, every step of the way. The hard part isn't searching, it's the checking yourself. It's actively going through, looking for the source that would prove you wrong, not just the ones that confirm you're right. If you start with a conclusion, you can find evidence for almost anything. The only way out of that is to start with a question instead. As far as radiometric dating is concerned, there are many types, not just carbon-14, and each of them use various methods to determine their accuracy. Ultimately, even if carbon-14 was found to be flawed, we still have many other methods of radiometric dating that have been working effectively mapped to real historical events. And I hope you found this process useful, and if you watched this entire video, then thank you for your time. All the best.